Hello, everyone. My name is Ian Moore, Technical Evangelist here at Appsilon. Welcome to the first Shiny Gathering. Before I get started, I want to quickly introduce you to the concept of the Shiny Gathering. To be honest with you guys, we aren't really sure what this model is going to be. We wanted to try out this experiment. Where at its core, what we want to do is on the last Tuesday of every month, we want to bring you a leader from the Shiny community to dive into specific topics, hopefully open a discussion. Ideally, we all learn something from this. But before we jump into it, I need to quickly remind everybody of our code of conduct, which we'll find in the comments below. At its core, we want this to be an open environment for everybody. So discrimination, hateful or abusive language, or in general, if you just came here to start a fight, that won't be tolerated and we will remove you from the chat. So today, I can't think of a better person to kick off these gatherings than Pedro Silva, who is a senior staff engineer at Appsilon. Pedro, despite being a really fun and creative, unique guy, kind of has a unique story of coming to the Shiny community. I think it's no surprise that typically a Shiny engineer starts as a statistician, data analyst, data scientist, then they move to Shiny, then they start learning some of these more advanced web concepts. Pedro had kind of a reverse kind of journey to Appsilon, where he started as a web developer, spent 8 years as a web developer before joining Appsilon as a full stack developer. So despite many of his many open source packages, his contributions to the open source packages here at Appsilon, Pedro is also one of the grand prize winners of the 2020 RStudio Shiny contest. So today, Pedro is going to be presenting a talk titled "Getting the Most Out of Your Shiny Apps, Leveraging Web Technologies in Shiny." I won't take any more of Pedro's time, so go ahead and bring Pedro on. Hey, Pedro.
Hi, everyone. Thank you for such a, I don't know, I'm speechless for that kind of introduction.
All right, well, I'm going to leave you to it then, Pedro.
Thank you. So you should be able to add my slides as well. Maybe a tiny bit bigger. Beautiful. Okay, so welcome everyone. Like Ian said, today we're going to be talking a bit about web technologies. I will try to be fast, although I must warn you, I did get a bit excited with this and actually have quite a few slides. But I will try to go fast so that we actually have a bit of time to just go through questions and maybe have a bit of a discussion. So Ian already did a great job introducing me. So like he mentioned, I have been a Shiny developer for the last 5 years, but I was also a web developer for a very long time before this. And I do think that this gives me a bit of a unique view on Shiny because I didn't actually grow up with R. I grew up with all of the web stuff that makes the web move, and moving to Shiny was actually quite interesting. And a bit of a side quest here. I still remember the first time I actually looked at Shiny and R code, and I honestly felt a bit overwhelmed. This is so different from everything that I've used so far. But as I got more and more familiar with it, I could see a lot of parallels with all of the other technologies that I actually used for web development. And when that clicked, I think this is also when I just realized Shiny is a conduit to do really a lot of cool stuff in web. Yeah, so socials, you can follow me. I also have a couple of packages on Cran if you're interested. A lot of them also related to web technologies. But let's get started. Okay, so if we're going to talk about web technologies, what actually are web technologies? The broad definition of web technologies is just software, programming languages, protocol, standard, basically anything you can use to build websites and web-based applications. This technically includes everything from front-end technologies that the users actually see when you open a browser to anything that works in the back end to power these applications. And yes, this does mean that R is with the existence of Shiny. This does mean that R is technically also part of these web technologies, even though it's not its main use. did became something that also powers web technology. Of course, the entire ecosystem is massive. This slide doesn't even do it justice. Technologies are everywhere, are everything, and there's a lot to talk about. But today I wanted to focus on three specific ones: JavaScript, HTML, and CSS. Why these three will become apparent as we kind of go through all of these slides. But in general, these three kind of make the backbone of the modern internet. Basically, anything that you open in a browser will, in some form or other, have some HTML, some CSS, and most likely some JavaScript. They all have very specific, they all do very specific things in the browser. So HTML kind of defines the structure of your content. CSS kind of determines how it looks like, what is it, where does everything kind of stand. And JavaScript does everything related to interactivity. So they kind of this holy trinity of technologies, and they're kind of this holy trinity of technologies that basically just builds the core of anything that you actually see in the browser. So just to give a very short introduction about each of them. So like I mentioned, HTML is more about the structure. It's technically a markup language, so never say that it's a programming language, because some people get very annoyed with it. But it is a markup language, so it does let you define more or less the elements that you have in the page. And in general, it just lets you structure all of these. So it lets you put text, it lets you put images, videos, audio, pretty much anything that you'd like to add to a page does need to have some kind of HTML representation. And if you're not sure if you have ever actually seen HTML, it typically looks something like this. So it's just a set of tags inside of other tags that kind of make this markup of a web page. The second one is CSS. So like I mentioned, it lets you control the styling of the elements. And in general, it kind of describes how things look like and where things are by simply using just a very simple system of statements. So it lets you specify what is the element and then add a couple of rules that are specific to CSS that let you kind of change the way it looks like. Just a bit more deep into the CSS thing. So all of these things, of course, have names. In the case of CSS, anything this is a CSS statement, and it's made by having a selector and then these curly brackets. And inside of these curly brackets, you have these pairs of properties and values, which are declarations. And technically, you can have as many as you want. There's hundreds of CSS properties and property value pairs that you can use that will pretty much let you just define how anything looks. And finally, JavaScript. So JavaScript is basically the programming language of the web. I know that nowadays there's a lot of programming language of the web's wannabes. So there's a lot of languages that kind of say that they can be used for creating things in the web, and it is true. But JavaScript is still kind of the core. Like, if you know JavaScript, you can do something for the web. You don't need to have any other language. It runs natively in the browser. It pretty much just any other language that you would use most likely will somehow use JavaScript, either to glue itself to the page or would be kind of converted to JavaScript down the line. This is the case of things like TypeScript, for example, which is a superset language of JavaScript. And JavaScript also has a very interesting property, which is it can manipulate both the HTML and the CSS of the page. So this means that it's actually quite powerful as a skill, because if you can make a bit of an HTML structure and then add a bit of styling to it, and then you can actually use the JavaScript to manipulate what you defined. This means that you can pretty much use JavaScript to change anything in real time. Yeah, and typically it can be in a lot of different places. It is a scripting language, which means that it can live in different HTML tags via specific attributes that we'll talk a bit more. It can be scripts, it can be global, it can be it's a very tricky language because it can pretty much be anywhere and will have access to everything. There's some frameworks that try to stop this, but it is a skill that we can use specifically in the context of Shiny. Okay, and just so you don't call me a liar, any I invite you to open pretty much any page on the internet, and if you do observe a bit of the source code in that page, you will find all of these three. You'll find a bit of HTML, you'll find a bit of JavaScript, you'll probably a lot of JavaScript nowadays, a lot of CSS. Any page has these, like is the case of Posit page here that I took as an example. Okay, so after that very painful introduction to the holy trinity of web technologies, why should we use it? We're Shiny developers. We're not web developers. Why do we actually care about this? Well, Shiny is a web framework. You probably heard this 100 times in the last couple of years. I think it's becoming more and more of a spoken thing that Shiny is just a web framework. So like any other web frameworks, it has some browser side. The uniqueness of Shiny that it kind of uses R as its backend. This is a very much just an approximation, a very big simplification of what Shiny is, and of course there's a lot of other pieces of technology that kind of go into here. But I like to think of Shiny as having these three main areas. So the browser, where users can actually see the application, the communication that works between the browser and the server, and the server itself, which we think about it as R, but there's actually a lot more that goes into just serving the page, actually making sure that all the different dependencies are available. So I just added here some of my favorite ones, some of my favorite technologies that are used in that specific part. Please don't. There's a lot more that goes here. There's an infinite list of technologies and small bits of magic that kind of go here. And like I said, I kind of wanted to focus more on this browser part, which is where our holy trinity comes into effect. So Shiny, I even like to think of it that Shiny is a bit more than just a web framework. It's actually a way, and probably the best way, to bring R and web together. So actually, there's a lot that we can do from Shiny and from the R side that will also help us get a better browser experience. Yeah, and of course, I think a good way of looking at it is also that the output of a Shiny application in the browser is just these three web technologies. There's a bit more, but these are the ones that we're kind of focusing on. Okay, examples. So you probably recognize this guy. I think this was the first application that I also had contact with when I started playing around with Shiny. It's our good old faithful. And just so you believe me, you might notice that all of the dependencies here in this specific Shiny application are also very similar to the same style that we had in a simple website. So there's a bit of CSS, a lot of JavaScript, and there's also a bit of HTML. And the one thing that I can tell you is that learning how to leverage these three, HTML, CSS, and JavaScript, specifically in the context of Shiny, will give you superpowers. It's really crazy the amount of stuff you can do using Shiny as a base, and then kind of starting to just add your own magic sauce and your small changes in these specific languages. Okay, enough selling out these three. How can we actually do this? So let's take a very, very simple example of an application. So this is my production grade ready application, which is a simple button that when you click it, it shows you how many times it was clicked. That's it. That's the entire application. You can see the definition here. This is just a pure Shiny application. It has an action button, it has some output, and then it has a server that just, whenever something gets clicked, will will update this output. So the first thing is, most likely you show this to your boss and they're super happy, and then they say, "Can you make the button blue?" Yeah, I mean, if you're not familiar with these three, this might become a bit tricky because this isn't really something that you had to do. You just had to do a button. It doesn't typically it doesn't matter what color the button is. The cool thing is, because we talked about CSS before, you might have an idea of what it would take to make this button blue in the context of HTML and CSS. So basically what we would like is, we would like to find that button and we would like to change the color. And in addition, we would actually also like the color to be slightly different whenever we hover the button. So we would like to add two CSS statements and have it somewhere. And this should make our boss happy. The problem is, how does this actually work in Shiny? How can you do this in Shiny? And if you're not aware, I will tell you now, but anything in the UI definition of Shiny is HTML, CSS, and JavaScript. And you can quickly check this in your RStudio IDE if you would like. If you just run this fluid page function in your console, you will get something like this. You'll get just pure HTML. So does that mean that everything is HTML? Yes, everything. Even the action button that you define actually just generates a bit of HTML code. Everything in the UI is HTML. So we have this. So now we kind of know a bit more that we can use CSS because this is HTML. We can somehow target this element and create our own custom HTML. So HTML itself is a bit more complicated, but it kind of follows any piece of HTML kind of follows three basic rules. The first one is that it's typically a tag. It's just a tag. In this case, it's a button tag, which is one of the base tags that HTML provides you. It has a couple of attributes. In this case, it has an ID, a type, a class. Each of these have some values as a string. And finally, it has some tag content. Now, the cool thing is tag content can also be other tags, which means that you could end up with something like this, where you have tags inside of tags inside of tags. Okay, but let's focus on our button for now. So if we would like to create CSS for this, we can actually focus on this class part. We can technically use any of these attributes or even the HTML tag itself to find our button. But by default, class is actually the thing that connects CSS and HTML the best. Okay, so let's look at our class. And we do have an action button here, which is exactly what we were looking for. So if we find a way to add this CSS to our Shiny application, we will have exactly what we want. So how can we do that? Oh, sorry. I need to skip something. Okay, I'm missing one thing. So while we could use one of these classes to create our CSS, it's typically better to create our own classes for elements when we're trying to customize them. And the reason for that is that, especially in the case of Shiny, if you somehow edit the styles for one of these classes, you might end up with um, something not working correctly. And this is because by default, Shiny adds a lot of CSS, adds a lot of styling by default. So a good way of avoiding that is actually to define our own classes for this. So instead of using action button, let's think of some other class that we can use. And let's think of how we can actually add it. So we know that these are just named attributes, and um, action button is one of the better examples. So action button actually has an ellipsis argument that says named attributes to be applied to the button or link. So named attributes is exactly what we want. We want to add another class to our classes. So this means that we could just add a specific class to our action button. And this will actually generate a slightly different HTML. It will actually generate some HTML that has our custom class here. Cool. Not every Shiny widget is as generous as the action button. So I will leave you with a trick that will work for every piece of UI code, which is this tag append attributes function. It's from Shiny. You can pipe it into pipe any element into it, and it will pretty much do the same. It will let you add any named arguments to that class. The cool thing here is that even if there is no ellipses or no specific argument to do that, it will also work. Okay, so any of these would work. Our button now has a custom button class. Now we just need to add the CSS. And adding the CSS, there's a lot of different ways of doing this. I will focus on three. The first one is adding the style directly to the tags. We can also add it as its own HTML tag that just kind of lives in the page. And finally, we can add just a file. So what would each of these actually mean? So adding styling directly to the HTML tags would just mean that we can actually use that ellipsis, and we could use the style named argument to kind of do something similar, where we just add some CSS attributes to that tag. This is a slightly different way because it doesn't really require us building those CSS definitions. It kind of just works in the element where you define it. I do not recommend this, even though I use it quite often. It's really nice for debugging. It's really nice for trying out stuff, but it's not really good for production. It doesn't allow us to do, for example, that state styling. We wanted to have some specific styling for when we're hovering the button. You cannot do it like this. It's also, depending on how big your project is, this is also a sure way of just losing track of where the color of the button is, because now you need to track the button, but there's 10 different buttons in 50 different files, and it's just a mess. It also means that you will need to define these for each instance of that element. So if you have 5 different buttons and they all need the blue background, you'll need to manually add it to each button, which also means that if your boss tomorrow decides that the button needs to be red, you are going to need to find every single instance of that button and change it. It's also hard to keep consistency throughout the project, exactly because of the same reason. You're going to need to go and hunt for every instance of the style that you did. And in general, it's just hard to implement large changes. Okay, so let's skip this one. Let's instead add it to our HTML. And in Shiny, well, in HTML, you can do this by using a style tag. Shiny has a very comfy element called tags that you can use in your UI definition. And inside of that, you typically find most of the HTML tags that you'll need. So here, for example, I want a style tag. Style tag is a tag that exists in tags. With this method, we can actually just instantly add our CSS definitions that we actually added, and this will work. So right now we have a button that has a custom class. and our style lives somewhere in the page, this just works. It seems to be great. Well, almost. It's slightly better. It does allow you to reuse the code because now you only need to have an instance of the code. Uh, Depending on how much you add, it does make life a bit. It does make reading the code a bit more complicated because we're talking about one caller or two different CSS rules, and you can see they already take like half our UI already doubled in size. It makes it very hard to read, and you can imagine if there's 100, 200, 300 CSS statements, your files start to be quite big. There's also one more hidden bad thing about this method, which is because it's being added directly to the UI definition, similar to how in R you would source a file into another file. This actually means that it cannot be cached by the browser. So typically browsers have a caching system, and if there's a bit of styling, they will actually cache it so that next time they don't need to download it. This actually doesn't allow for that. Okay, so let's make our own file. Clearly, it's all kind of building up into this. So how would that look like? So we just make a style, and in the case of CSS, is a .css file. And then we can add it to our UI definition. Now, I like to add it in the HTML way, which is with the link tag that says it's a style sheet of the type CSS, and this is where it lives. And because Shiny automatically loads the www directory, we just need to put this file there and give it the name here. And this file will be sourced with our UI. This is pretty much the best option that we have right now. It does mean that the code can be reused, it does allow caching, and it does allow even multiple files to be included. So you can kind of start adding a bit of a structure to your styles, where you can have maybe a file for layout, maybe a file for buttons, maybe a file for, I don't know, drop downs. And it kind of lets you organize things a bit more. Some of you might have noticed that I didn't mention include CSS. Include CSS is not really the same as using a tag link, a link tag. And that's because include CSS works exactly like sourcing. So it will pretty much just paste the code, and it's actually more similar to this solution than to this solution. Okay, cool. So we added color to our button. Everyone is happy. Well, not quite. Our boss wants more. Now he wants to add some kind of notification when the button is clicked. And of course, there's a lot of ways of doing this in Shiny, but I will give you a JavaScript version of what something like this could look like. And also, instead of an alert notification, you could just run pretty much any arbitrary JS code. Again, fire. So let's go to JS. There's four main ways you can actually add JS to your code. These might look a bit familiar just after we went through CSS. So you can add it directly to your HTML elements. You can add it with the script tag, and you can add it as a file. If you're building an R package, you might also be interested in HTML dependencies. I won't go too deep into it, but it is also a way to kind of manage your CSS and JS dependencies. Okay, so adding code directly to the HTML elements. This is also done by using HTML named attributes. So in this case, we can just add a bit of JS code, and the named attributes represents the type of event that we would like to track. In this case, whenever someone would click this button, it would just print a message. This is an okay solution. I often use this not with the code directly, but to invoke, for example, a function that's defined somewhere in a file. This is pretty useful. It's also worth mentioning that there's a lot of events. I couldn't even actually paste the entire list here. It's probably 10 times this small screenshot. It just lets you register all kinds of different events in different elements. So you can have on click, on change, on hover, on pretty much anything. There's probably a JavaScript event for it if you can think about it. And like I mentioned, they combine really well with functions, simply because you can do the event and then invoke the function, and the function, the actual definition, just lives somewhere else, typically in a file that was just sourced. If you're more interested, there's the entire list of DOM object events. I'm pretty sure that these slides will be shared later, so don't worry. And in our case, for the action button, what we would actually need to do is just define a named attribute on click that calls the alert function from the browser. And that's it. Okay, so second one, adding it as a script tag. This is pretty similar to what we did with CSS. So we add, in this case, instead of a style, we add a script tag. We do a bit more of a convoluted way of adding the event. So in this case, we find our element by using a JavaScript selector, and then add the click event that does exactly the same. You could use the on click plus the function definition. I just use this as a slightly different way of showcasing how it could work like. There is one thing to mention here. Script tags can be added anywhere in the UI with any bit of code. They will run once. So whenever they get loaded, they will run. So in this case, this script tag will add the event to that HTML tag. And another thing is they will run by the order of execution where they are. So this means that if you would have this script tag before the button, it actually would fail because the button technically doesn't exist at the point that you run it. There's a couple of JS ways around this where you can kind of delay running the code until later. The best solution would be to have an on-click that invokes a function. The function is defined as a pure function, so it doesn't really break anything. And finally, the idea of adding the file. Again, super similar to the styles. The syntax is a bit different. We still use the script tag. In this case, we just give it a source with the path to the file. And in the file itself, we define, we add our code. In this case, it's the same code that's here. And yeah, that's it. Best reason to use files, readability, similar to CSS. It just lets you keep your JS code out of your R code and just makes life easier. This is much easier to read than something like this. At least I believe so. Okay, I won't touch HTML dependencies. There's a lot of documentation about this. It is worth looking into if you're building a package, because it just kind of lets you group all of your dependencies and then source them in one specific. It lets you source all of your dependencies only once instead of actually having to add all of this manually. And also some tips on debugging. I saw that someone already mentioned that there's a browser console. Yes, there's a browser console. So if you're new to JS, console log equals print in R. So it will just print something in that browser console. And debugger in your JavaScript code is the same as browser in R. So it will stop the code there and kind of let you go in and start messing around with the environment. To open the console, it depends on the browser. Typically, you can either right-click inspect or Control-Shift-J, I think, in Chrome will also do this. Okay, there's one last thing about JavaScript that's also worth mentioning. So we talked about adding JavaScript, but we're not really doing integrating it with Shiny in any way. There is a mechanism to do this built in Shiny. There's a couple of different ways, but I think the one that should give you the most use is custom messages. Custom messages let you pretty much either trigger things in the browser from R or trigger things in R from the browser. So in this case, if you would like, for example, to trigger some JavaScript function from R, you can use in your server, you can use this session $ send custom message. This just takes some ID that got registered in the browser and a message. The message can be pretty much anything. In the JavaScript side, you need to add a handler, which will have the same ID, and then a function, and then you can just define the function. So whenever you do this send custom message, because you registered the handle, it will just call that function. The other way is slightly easier. So in JavaScript, you can actually just use shiny.setInputValue. Shiny set input value only takes an ID and a message, and this actually it becomes something that you can just observe as a normal input. So if you do input $, whatever ID you define on the set input value, it will actually update the value with that message. Uh, there's there's a lot of things you can do with this. You don't need to have the input already defined. It can be a completely new input. Better yet, it's better if it is a completely new input. But it basically just lets you do this one side messaging to Shiny. Yeah, and I very much recommend using these specifically when you're working with code that you already have in JavaScript and you just want to kind of link it into Shiny. It's also a really great way of offloading some computation. So if you have, for example, a Shiny function that will update, I don't know, the style of 100 buttons, it's probably better if you just have a JavaScript function that does this and you just send a custom message to the browser and the JavaScript side takes care of it. Some examples for this, there's two projects that rely very heavily on custom messages and also a bit on HTML and CSS that we talked about before. All of the code is open source. You can go around, dig, and if you find any bugs, just let me know. Okay, so quickly, things you can already use today that are technically related to web technologies. So as you know, cron is getting bigger and bigger. It's already on 20,000 packages. For sure, somewhere in the middle of all this, someone created something that uses web technology. And of course they did. So the first one is that I would recommend. And again, these are just some of my personal preferences, doesn't mean that you should use them. The first one is HTML tools. So HTML tools, if you've ever used Glue, it's a very similar concept, but it's specifically for HTML. So if you have a bit of HTML that you would like to reuse, you can use HTML template to kind of just use that in your UI definition. It lets you have these double curly bracket spaces where you can actually just pass it name arguments with other UI definitions. The second one is Sass. So if you're already getting tired of CSS or if you have really a lot of CSS, Sass is basically like a programmer way of dealing with a lot of styles. So it lets you generate styles, but it also lets you organize them in a slightly different way, lets you use variables. It's very comfy and a much better way of organizing CSS. My own Imola package. So if you're looking for something that does layouts, specifically if you're getting into CSS, you might start reading a lot about grid and flexbox. Imola is just a way of doing these directly from R. It has some really cool stuff. I try to use it as much as possible because even though I did tell you that you shouldn't add styles in directly in R, if this is an R function, then it's okay. That's my stance, and I will stay by it. Shiny.js. So if you're still new to JavaScript, but you kind of want to use some of the JS stuff that we talked about, I do recommend getting started with Shiny.js. It's pretty much just an R wrapper for a lot of the stuff you can do in JavaScript. Another one, a bit more specific functionality, progressive web apps. So these are whenever you open a website and it kind of gives you a button, would you like to add this to the homepage? This is a piece of web technology that exists. There is a R package specifically for that. I think it's hard not to mention WebR since it's so new, but yes, WebR is also a piece of web technology that you can technically add to your Shiny applications. It just lets you run R code in the browser. There's no Shiny R WebR version, but it does it does show a lot of promise, and I'm super excited about it. And what about all the things that don't exist? Well, for the things that don't exist, there's also some really nice folks that did some really nice packages. The first one is HTML widgets. So a lot of the really complex visualization things that you might have used already, things like eCharts for R, Reactable, HighCharter. These are built using HTML widgets, which is a scaffolding package to actually wrap complex JavaScript applications. It's super easy to use. You just need to define a couple of files, and you're pretty much ready to go with the new JavaScript based R package. If if whatever you would like to use is based on React, you can also look into Shiny React. It's pretty much like HTML widgets, but more for React specific packages. And if it doesn't exist, you can probably make it. So by now you should have at least realized that everything is HTML, CSS, and JavaScript. So even if you're not using, or if you're building something from scratch, you can probably wrap it in a nice R function and still be able to use it. Finally, what about limits? So is there any limits to what we can do? Well, kind of, but just to give you an idea, there's dozens of UI frameworks that just build in CSS and maybe with a tiny bit of JavaScript. So all of these could technically be used. And there's 20,000 packages on CRUN, but there's 2 million JavaScript packages on NPM, which is the main repository for JavaScript libraries. So from 20K to 2 million, for sure, there's some stuff that you could also port to Shiny quite easily. Yeah, and that's it. So I think I didn't overstay my welcome too much. I know that we would like to. I'm sure you have a lot of questions. So let me know. Ian, maybe you caught some already. Maybe we can kind of get it started.
Yes, Pedro, we have a few questions that came in. The first one is from the great Eric Nance. And since we have this functionality, sorry, something jumped there for a second. Since we have this new functionality, are there any any of these three methods easier to debug when using the dev console to experiment with making changes in real time?
So I assume you're talking about the JavaScript part.
This was the CSS section, in fact.
Oh, about the CSS?
Yeah.
Not really. So whenever you're inspecting the actual elements of the page, and maybe you can share my screen just a bit more, and I will actually show you because it might be a bit easier.
Sure.
So I will just share exactly the same screen that we had before. Oh, I can see that it doesn't really quite work. Now it's just a thing from the sharing, so I cannot share the whole window. It only shares the tab. But when you open the console, so you can stop sharing. It's fine. I can just mention it. When you open the DevTools console, you get access to pretty much all of the HTML, all of the CSS, all of the JavaScript that's running in the page. When you select a specific element, it will show you the styles that get applied to that element. So I believe that having generic rules still make it a bit easier, especially because if you're editing it in real time, you will see all the changes in all the elements that that specific piece of CSS actually hits on. If you have these in line, or if you're just talking about one specific element, all of them pretty much work the same.
All right, thank you for that answer, Pedro. So for the next one, Albert Rapp, it's so great to have you here. Is there a way to watch these changes in CSS files so that I don't have to relaunch the app to make style changes?
Yes, and in the case of Shiny specifically, there is a property that you can use, and I completely forgot the name of it, but there is an option, which I believe is either hot reload or on reload or something like that. There is a Shiny options, and I'm totally not Googling this right now, but there is a set of options in Shiny. And again, you can share my screen again. I think this will be also kind of useful to show. So these are global options specifically for Shiny, and I can see that I can do this.
Perfect.
So there's a lot of configuration options like flags that you can set up in your R project that will pretty much help you with debugging with a lot of different options. One of them is this Shiny auto reload. So Shiny auto reload will basically refresh the app every time something changes. It can be a bit annoying if your Shiny app is a bit too big because then you need to deal with all the loading and everything. But this is an okay way of kind of tracking it.
Okay, great. No, thank you for showing that, Pedro. So if anybody has any other questions, feel free to put them in the chat. But I guess with the remainder of the time, if we don't get any other questions, actually, no, Eric Nance, right on time. Let me just remove this really quickly. All right. So if you find an HTML widget package that does 95% of what you want, what techniques would you use to add custom JavaScript that's missing from the package?
Okay, so the first one is, can you make a PR? So we are in R, so open source and everything. So if you can add this functionality directly to the package, this is definitely something that I would recommend. If this is not an option for some reason, you can always wrap your custom functionality in another package. So typically, it's not uncommon that that we find a widget that does pretty much what we want, but it's missing either a bit of additional styling or maybe a bit of functionality, like Eric mentioned. It's okay to take that widget and wrap it in our own function and kind of add the missing pieces that we need. So in the case of styles, this would be, instead of just calling the widget, we would call our widget that also adds, for example, another style tag or another script tag that has a bit of extra functionality. Yeah. So if you can do it in the original package, great. If you need to extend it, this is also fine. I would typically just wrap this around my own function using the other function as a base.
Thank you for that answer, Pedro. All right, and right on time from Albert Rapp. Do you recommend a specific learning path for HTML, CSS, JS? Is there like a tested way to learn these technologies fast slash efficiently?
So I'm a bit on a unfair position because I did have to grow almost 10 years or even more now. The COVID kind of blurred a lot of years together. But I kind of had to grow slowly with this. I do think that specifically in the case of JavaScript, there's a lot of frameworks, a lot of packages that people talk about. So, for example, should I learn React? I mean, you can, but specifically in the context of Shiny, you will definitely get more from learning just base JavaScript, vanilla JavaScript, than you would from learning like an actual framework. Yeah, so my recommendation is just when it comes to HTML, to kind of see what tags are available. There's quite a few tags that we can use. So just being aware of these is great. Don't get caught in the trap of tags that don't exist, because there's also a system of registering your own tags for a specific page. So this could also trick you down a bit, but just knowing the base ones, so your headers, your paragraphs, your spans, what are the base properties of them? is a really good way to start because they all have small tweaks that kind of make them different from each other. When it comes to CSS, kind of the same. Just play a bit around with it. There's a lot of there's hundreds and hundreds of CSS properties, but there's probably like 100 that you will use in your lifetime. There's a few more obscure ones, but most of them are 80% of the time you're just going to use those 20, 50. I do recommend looking into specifically the grid and flexbox for layouts. These are super powerful, and I think it's also it. There's this misconception that HTML should define the way things look like, and a really good example of this is every time you see a bit of shiny code and there's a BR somewhere in the UI, that BR is used for layout. If you keep your HTML as slim as possible and only use it to actually list the components that you need, and then use CSS to actually set these up in the screen, you're going to have 100 times easier time in the future because then you can add different layouts depending on different screen sizes. You can pretty much change the way it looks without having to touch the HTML ever again. And when it comes to JS, it's the same. So just playing around a bit with vanilla JS, I think it will get you really far in the Shiny world. When you get more comfortable with it, you can start looking into TypeScript, which is also a preprocessor for JavaScript. It also lets you organize massive amounts of JavaScript code much easier. You can look into jQuery as well, which is it is something that is bundled with Shiny right now, and it's an easier way of actually calling a lot of these JavaScript functions that we saw. But I'm not sure how long it will stay. So please take this with a grain of salt because it is a very old piece of technology. Yeah, so I think that's it. So I don't have a lot of recommendations. Just learning the basics, I think, is a really good way to start.
Thank you for that answer, Pedro. I might add one recommendation. There's a YouTube channel called Web Dev Simplified that helped me immensely. I wouldn't know what React was if it wasn't for that channel, but that could be a good resource for people.
I can add one more.
Sure.
Kevin Powell
Absolutely is the master.
for CSS is great.
Absolutely great. Kind of echoing on Albert's question in a different way. If I needed to position a company logo in the app, where do I start to learn that? I guess as kind of a base example.
So the first thing is it would depend a lot on your UI. So if you are using something like a fluid page, or you probably want to add it in the top, which means that you probably want to have some reserved header space or a component that you would call your header. Most of the times you just need a bit of CSS for this. So if the logo is more or less where you want it to be, there's a chance that you either need to change a bit in the actual container of the logo. So maybe you just want to change the position. So again, there's a lot of CSS properties for this. I do think, and I might be repeating myself a bit too much, but CSS grid is a really good way of kind of letting you think of the layout more than the elements themselves. So if you do build a full layout using CSS grid, you probably end up with a small square where the logo is going to be, and then you just assign a logo there. I know that this isn't a very this isn't something that you can add to any project, so I would probably look into position absolute when it comes to CSS, and that might give you an idea of how to just add the logo exactly where you want.
All right, thank you for that answer, Pedro. So a minute ago, I completely agree with the statement that you made that like if you want to learn React, you need to learn vanilla JavaScript first, and you'll have a really tough time if you don't do that. Your slide came up about SAS, which people don't know stands for Syntactically Awesome Styling Sheets. I'm of the opinion that people should start to learn SAS first. And every time I open a CSS sheet and I can't nest things, I can't comment things out, can't use mix-ins, it's just so apparent to me. Do you think that kind of position still stands, that you should learn CSS before you learn SAS, or is this something that you would encourage people just to jump into?
So one of the cool things about SAS is that any valid CSS is valid SAS. So if you know the basic CSS, if you know basic CSS, when you make the jump to SAS, the first thing you do is you change the extension of the file, and then you can start playing around with it. So I do think that knowing the base CSS is a really good way to start, because it will let you incrementally make your styles better. Maybe the first thing you do is you use the nesting. So SAS does allow for nesting, similar to how HTML kind of lets you nest different tags. Maybe then you start playing around with mixins or functions or variables. But the cool thing is that if you start with base CSS, you can slowly add more and more of these SAS features. I typically like to use, for a very long time, my biggest, the thing I hate the most about CSS was that it didn't have variables. Now it does, and I still think that I still think that SAS is better, but you just add the CSS variables as well. It lets you do some really crazy stuff, like on real time changing the entire colors or the sizes of the applications now. It is a game changer, and I'm also super excited about container. This is probably not going to make sense for a lot of people, but there's a CSS media query that so CSS allows for attributes, and attributes are basically things that you wrap pieces of CSS around, and the CSS will only be active in those conditions. Media used to be the way that you make, for example, different CSS for different screen sizes. There's a new one coming out that kind of already has a lot of new browser support, which is @container, which actually lets you create different CSS rules depending on the size of your widget. So you can kind of see that this is gonna let you do some really crazy stuff when it comes to CSS. Again, these are all from vanilla CSS. If you know these, you then can just add a bit of SAS on top of this.
Thank you for expanding on that, Pedro. So my next question is, I guess, kind of a personal question, because we see different CSS frameworks come along and then they get all exciting. And one of these that came around very recently, or in the past couple of years, was Tailwind CSS, where the whole idea is that all of your CSS is defined inline. Maybe as just an open question, do you have any comment or opinion on that? Because I believe one of your main points is don't use inline CSS.
So it's slightly different, because SAS is also Tailwind is very much about support classes. So the idea of Tailwind is that you should be able to have a class for everything. And this kind of goes into the same idea that I was actually talking about, adding the custom classes. So if what you're doing with Tailwind is using all of those support classes as much as possible, this is kind of okay. I still think it's a bit verbose, but again, this is my opinion. I like to group them as much as possible. Better yet, I like to have some support classes, but I think that there's a limit to how many classes one component should have. Unfortunately, there's no hard cut on this, so you could technically have like dozens and dozens of classes. But I think that a lot of classes also make the actual code hard to read. This is why I prefer not to go with too many of them. Sass does solve this a bit because you could technically create specific mixins for specific groups of components and just reuse a lot of those support classes. I don't think you can do this in Tailwind. I know that there's a lot of cool stuff about Tailwind, especially the way it kind of processes the CSS to only actually have the things that you need. Um, as a personal choice, I prefer less verbose frameworks, but uh, it's a trade-off.
Excellent answer. So we're coming up on the end of the time here, and this is very much a general question. I think I've wanted to ask you this for years, or since I mean, I've known about you for years, but I've been wanting to ask you this. Since you started as a web developer, can you describe to us like what was it like coming to Shiny? And more importantly, like once you figured out what Shiny was, why did you decide to stick with Shiny?
Um, I think there was a slide where I mentioned that Shiny for me is more than a web framework. It's just a way of bringing R and now I need to find it. It's a way of bringing R and the web together. It is a web framework, and I do find it's a very flexible web framework. The fact that we managed to talk today about all of these things, about how low level you can go inside of a Shiny application, does mean that it's extremely flexible. Nothing is stopping you from taking any JavaScript framework that you like, slap it inside of a Shiny application, and build a lot of your UI using that. There's examples of this. React is all over the place when it comes to this kind of stuff. There's for sure there's other examples of other frameworks. We talked about Tailwind. Tailwind that you can use Tailwind in Shiny. You can use Bootstrap. You can use pretty much anything because it's that flexible. And the fact that it lets you do all of this front end flexibility, but still have the processing power of R is really impressive. It's unique. You can have a million rows in a data set and have it running in the server, and it will still work. There's not a lot of pure front end frameworks that let you do this. And of course, you can have APIs and all of that to kind of do some of this processing in the server hidden somewhere. But the truth is, there's not a lot that give you this option of having one single file where you define all of these things and run it for you. Specifically, when it comes to just trying out new concepts, Shiny is. I still think that Shiny is unbeatable on that. You will always be able to scaffold something together, and you can extend that pretty much indefinitely. You can slowly move more of the processing to the front end. Maybe you can slowly move some of the things to a database. You can keep building and building on your application until Shiny is almost non-existent. And maybe in the future, even maybe at some point, you even get rid of Shiny because you already kind of converted everything. But you kickstarted this super quickly, and every time you change something, it will still work. It's just I don't know. It's for me, it's like a really unique thing.
Thank you for your perspective on that, Pedro. So I guess this will maybe be a bigger, more open question, but you kind of already answered the first part of this. But what would you say are your favorite things about Shiny? And as the second part, what frustrates you the most about Shiny?
So favorite things, yeah, I think I kind of went through a lot of these. It is very flexible. It's super easy to get started. It in my specific case, it let me use everything I knew from web and then learn a tiny bit of R and just get started. And then as I started digging more and more into like the actual R side and how powerful it is as a language, uh, this was also one of the reasons why I kind of stayed. Um, when it comes to frustrations, I think right now my only really big frustration with Shiny is still the way it does the communication with the server. I know that there's probably better ways of doing this, but the way that it requires a WebSocket. So you ran into this 100 times already. The fact that your app just grays out, and it grays out because it lost connection with the server. And unfortunately, there's no way of kind of reconnect without refreshing the page. And this is just because of how WebSockets work. So WebSockets, it's complicated. But while it works really well, uh, I still wish there would be like a slightly different way of doing this. That would be a bit more just easy. And maybe WebR will eventually save us here.
Well, I wish we had time for me to ask you more and more questions about WebR because that's certainly very interesting. But we're going to have to wrap it up today. So Pedro, thank you so much for volunteering to be the first host of the Shiny Gathering and the first speaker. We really enjoyed having you. I know that I learned something today, so I hope everybody in the audience learned something as well. Do you have any final comments before we head off for the rest of our day?
No, just thanks to everyone that joined in. Thank you so much for having me. I will see you around. I know there's going to be one of these every month, so just stay tuned for the next one. And I might not be presenting, but I'll probably be in the chat also.
All right. Well, thank you so much, Pedro. All right, everybody. That concludes the first Shiny Gathering. Thank you guys so much for joining us. And if you're watching this on YouTube, thank you for tuning in. And just to let you guys know, once again, I'll say it that we're going to be doing this on the last Tuesday of every month. So the next one is going to be on May 30th. And it's going to be how to build Shiny testing architecture with Marcin Dubel. Two other things, if you didn't already know about our Slack channel, we have the link in the comments. And I'm just going to shameless plug here because I'm the person who collects all the information for our Shiny Weekly newsletter. If you aren't signed up, that is information collected by a real person who really cares about Shiny. That's how I spend my Monday afternoon every week. So if you're not signed up, please join us for that. And once again, thank you guys for being here today, and I hope you have a great rest of your week.